In this video, I'll be explaining photoelectron spectroscopy. Imagine this tennis ball representing an electron, and me, the nucleus. The stick, the space between the electron and the nucleus. Here, there's a small space between the electron and the nucleus. Now, there's greater space between the electron and the nucleus. So basically, photoelectron spectroscopy is just a white boy with a lacrosse stick and some balls. I mean, this doesn't mean that there's a little me in every science lab, but rather the concepts are alike. So what's happening is that me, the nucleus, has some electrons, the balls, that orbit at different lengths, like how I hold the lacrosse stick at different lengths for myself. So basically, what's happening with photoelectron spectroscopy is that scientists, in all their might and glory, learn that we can identify the relative energies of electrons in atoms and molecules if we blast them with high energy radiation, essentially throwing the electrons from the atoms or molecules and having them land on a sensor, and the distance that they traveled tells us how much kinetic energy they were storing and what their energy level was. Now, a lot of y'all might be wondering how this would look in a lab, so therefore I provided a representation of how this procedure would go. We have our laser, or in our lab, the Death Star, and our atom, again, me as the nucleus with my tennis ball electron. Now, the Death Star is going to shoot a UV ray at me, which in our result knocks my electron loose, causing it to release its stored kinetic energy and fly away from me. We're jumping back to our Bohr model here for a second, and y'all are probably already conceiving your own results as to what would affect the outcome of photoelectron spectroscopy. Now, if y'all are guessing distance, then you are right. The greater the distance between the electron and the nucleus, the less tightly it's bound to the nucleus, and therefore the easier it is to be knocked loose. So if you have some valence electrons in comparison to innermost electrons, the valence electrons are going to be able to be knocked loose a lot easier and therefore fly a greater distance than the innermost electrons. So the sensor will show a graph that looks a lot like this, with the innermost stalk being closer to the nucleus and therefore tighter bound and traveling a lesser distance, with the outermost stalk being the valence electrons and traveling the greatest distance. And now we have this fun aerial shot of me throwing the tennis ball or the electron and it landing on the street, or the graph. Of course, representing how photoelectron spectroscopy throws the electron away from the nucleus. I hope you enjoyed this video by Gabriel Watts Productions, and I will see you on the next one.
Merry Christmas.